iron plating and electroforming are two related processes used in various industries for a variety of applications. Iron plating is a process where a layer of iron is deposited onto a metal or non-metal substrate using an electric current. Once the desired thickness of iron has been deposited, the substrate is removed from the plating solution and washed to remove any residual electrolyte solution. The iron layer may then be post-treated with various chemical treatments to improve its properties, such as hardness or corrosion resistance. There are several different methods of iron plating, including electroless plating, which does not require an electric current, and electroplating using different types of iron salts, such as iron sulfate or iron chloride. The specific method used will depend on the application and the properties desired for the final product. Iron plating is also commonly used in the production of rubber tire molds, where it is used to provide a durable, high-quality surface on which the rubber can be formed. The iron layer acts as a release agent, preventing the rubber from sticking to the mold surface. Electroforming is a specialized form of electroplating where a thin layer of metal is deposited onto a substrate to create a precise replica of a master form. In this process, the master form is coated with a conductive material, such as copper, and then immersed in an electrolyte solution containing the metal that will be deposited. A current is then applied, causing metal ions to deposit onto the surface of the master form. Over time, a thin layer of metal builds up on the master form, creating a copy that is an exact replica of the original. The copy can then be removed from the master form, and the resulting metal part can be used as a mold for other manufacturing processes. Iron plating and electroforming can be used together to create high-quality molds for a variety of applications, including recycled plastic. To create a mold, a master form is first created using a material such as wax or plastic. The master form is then coated with a layer of conductive material, such as copper, using a process called sputtering. This process is also known as electroplating, and it involves immersing the substrate in an electrolyte solution containing iron ions and a source of electric current. Once the master form is coated, it is immersed in an electrolyte solution containing iron ions, and a current is applied. Over time, a thin layer of iron deposits onto the surface of the master form, creating a negative mold. Once the iron mold is created, it can be used to create positive molds for the manufacturing process. This is done by applying a layer of plastic to the surface of the iron mold using a process called vacuum forming. The resulting positive mold can then be used to create the final product by injecting recycled plastic into the mold cavity. In summary, iron plating and electroforming are two related processes that can be used together to create high-quality molds for a variety of applications, including recycled plastic. There are several practical considerations to keep in mind when working with electroforming. Master form preparation. The quality and preparation of the master form are crucial for successful electroforming. The master form should be precise, smooth, and free of imperfections. Any defects or irregularities on the master form can be replicated in the electroformed part. The master form needs to be coated with a conductive material before electroforming. Copper is commonly used as the conductive coating, but other materials like nickel or silver can also be used. The coating should be uniform and free of any gaps or discontinuities to ensure even deposition of the electroformed layer. The choice of electrolyte solution depends on the desired metal for electroforming. Different metals require specific electrolytes. For example, copper electroforming commonly uses a copper sulfate electrolyte. It's important to use the correct electrolyte and maintain its composition and temperature within the recommended range for optimal result. The substrate acts as the cathode, and a piece of iron or another metal is used as the anode. When a current is applied, the iron ions in the solution are attracted to the cathode. where they deposit onto the surface and form a layer of iron. The current density, plating time, and other electroplating parameters should be carefully controlled. These parameters affect the rate of metal deposition and the thickness of the electroformed layer. Precise control is necessary to achieve the desired thickness and maintain uniformity throughout the part. Proper agitation and filtration of the electrolyte solution help maintain consistent plating conditions and prevent contamination. Agitation ensures even distribution of metal ions around the master form, while filtration removes impurities that can affect the quality of the electroformed part. After the electroforming process is complete, the electroformed part may require post-processing steps, such as removing the part from the master form, cleaning, and surface finish. Care must be taken during these steps to avoid damage to the electroformed part and to achieve the desired surface quality. Electroforming involves working with chemicals and electrical currents, so it's important to follow appropriate safety measures, use proper personal protective equipment, work in a well-ventilated area, and handle chemicals and electrical equipment with care. Iron plating can be used to improve the wear resistance and durability of a substrate, as well as to provide a decorative finish. Iron plating is a widely used electroplating process, particularly in the automotive and aerospace industries, due to its ability to improve the corrosion resistance and wear resistance of metal parts. Iron plating can also be used to provide a decorative finish to metal surfaces. Before plating can begin, the substrate must be thoroughly cleaned and prepared to ensure that the plating adheres properly. This may involve degreasing, acid etching, or other chemical treatments. The clean substrate is then immersed in an electrolyte solution containing dissolved iron. Thank you for watching. Don't forget to please like and subscribe. If you have a topic you would like to suggest, leave a comment.